intro then. So first of all, big thank you to Nick for coming along here. So I'm sure Nick will introduce himself in a little bit, but I bumped into Nick a few months ago now at a meeting in Vericode's office. It was another DevSecOps meeting. Don't mind mentioning it. We work together with the different groups. So if you haven't come across it, it's called DevSecOps London Gathering, I think. So look it up. Really worth going to. Different kind of vibe to this group. So if you've not seen it, not heard of it, worth going along to. And especially because I met Nick at this meeting, and at that meeting, he was really kind and said he might be interested to come along and talk at our group. So thank you again. I'll let you get on now and introduce yourself.
Thank you. Thank you very much, Roy. Pleasure to see everyone here today. Thank you for those that have joined online. I just want to position this talk before I start on it, because the purpose of this session aligns really quite nicely with the directives for this group, because we're looking to provide people with an understanding of the foundational principles behind DevOps and DevSecOps. And you'll see as I go through this presentation, I don't go into a great level of depth here, but the idea is that you come away from this understanding a little bit more about the concepts involved, and I can share some kind of accumulated knowledge and kind of experience that I had from talking with customers about this. Throughout the presentation, obviously I reference a lot of historic aspects. I do that with a degree of reverence, because it's taken a lot of time and a lot of energy and a lot of brain power to get to where we are today. So if I'm a bit some subjects with a bit of levity, it's just in a kind of respectful way. So let me just tell you a little bit about who I am. So I work for a company called Vericode. We are an application security testing vendor. I'm here with my colleague Michael Mann as well. So after this presentation, you want to speak a little bit more with us, then we'll do that. But my role at Vericode is twofold. I spend a lot of time with customers talking about scan concepts, integrations, but I also have lots of sessions with customers who are looking for a more strategic view of what DevSecOps is and what it means in their role. And a lot of those conversations sometimes revolve around, can we educate our people? Can we educate our organization and our employees as to what these concepts are, because we are looking to shift our culture in this direction. Very briefly about me. So this is my first computer, a Commodore 64. It's led to a really unhealthy obsession with computer games ever since that time, which has cost an awful lot of money and a lot of my time. And I also recently have started doing a lot more cycling, with mixed results. Most of the time I'm falling off the bike, which is why you can't see me in the picture here. This is probably indicative of quite a lot of energy. So what I'd like to do is just give you sort of very briefly a kind of primer on DevOps. And this should give you an understanding of the foundation that really sort of led to what we consider to be modern DevSecOps. So if you think back before DevOps, we are looking at a structure which IT organizations adopt, which is quite segmented. It's quite segregated. You have very defined cost centers, business areas, functions, people working in relative isolation in some of these teams and in some of these organizations. And certainly you have software developers who are working to develop things. Once something is developed or a package is developed, that piece of software is then handed off to another team, and they go ahead and they kind of wait for the next sort of work package to come in. And so you have this kind of disparate teams of professionals who are all working in quite a siloed fashion. And this worked really well from a structural perspective. You can be very defined about budgets. You can segment things in terms of kind of work packages and things people are working on. However, there are drawbacks to this kind of structure, as we'll talk about. And software development very much focused on a project structure. So you can see here, for those of you that aren't familiar, this is a kind of a Gantt chart or a process workflow or waterfall workflow, whereby you have dependencies on something else completing, and those different teams are going to be working on different work items here, to wait for something to finish before the next can move on. And this, again, works very well from an organizational perspective, but it isn't particularly conducive to flexible software development. So you have this process whereby people are developing things in a very structured, ordered way, but that unfortunately leads to some less than desirable consequences in terms of what you actually get as a result of that work. And one of those sorts of undesirable consequences is that often when a new idea comes in for a feature or a capability or a software capability, is that the length of time from coming up with that new idea and coming up with that new concept, and it will take an awful long time to go from that all the way through to a piece of software which is in production. So that kind of length of time is dependent on lots of different teams finishing what they're doing, handing it off to the next team, and of course, as a result, you can have this great length of time between starting with a new idea or a new piece of software and actually entering into the hands of an end customer. And a lot of this is kind of based on the idea that teams very much collaborating by tickets. I've done my piece of the puzzle, I've thrown it over the wall, or I've handed it off to someone else. It's now their turn to work on this, and once they've worked on it, we'll come back to it. But this kind of collaboration really wasn't in this kind of mature state of actually day-to-day working with people. So very much a case of I've done my piece of the puzzle, it's now time to hand it off to someone else. And also automation as well. You've got some parts to this flow and this kind of project structure. There is limited automation there, so we're not seeing anything like what we would consider a modern automation picture. And you inevitably get this point where you have these kind of big bang releases. So lots of teams working up to a deadline, or we've got a kind of release schedule, and an awful lot of work has gone into something. We spent a long time developing something, and now we're at the point of pressing a button and everything goes live all at once. Now, this structure and this approach to developing software and releasing software, of course, if you are going to limit somewhat the experimentation or the flexibility for this plan, because any flexibility or change to this schedule has all of these follow-on impacts on other pages or items. So you, as a byproduct of this, you're kind of seeing less experimentation, less changes to that plan, and it can inevitably lead to things like polar uptime systems or long time to recovery. If something goes wrong, there's lots of panic. And you'd hope that actually, when you press Big Bang, you get this fantastic fireworks display and everything works fine. Inevitably, though, what can happen is it goes wrong, and actually you need an awful lot of pizza and an awful lot of coffee to sort this out. And this kind of mantra of don't panic kind of comes into play. So you can see how, as a result of this kind of way of working and this kind of way of thinking, a lot of people in the IT world and the IT field and in software development sort of led to thinking about, actually, is there a better way? Is there a better way we can do this that is more flexible, where we can get better results, where we don't have this scenario where everything goes wrong and we need help with kind of fixing a huge issue that happens. And when I talk to my customers, and we're talking about actually how did this arise, I think for me there are kind of two key foundations which kind of really led to what we consider to be DevOps. And I think the first of these, obviously huge influence, is Agile, the Agile manifesto that was introduced in the kind of early 2000s, which looked at shifting the perception around how teams work to develop software to be more flexible, be more collaborative, and work to change from a project-based mindset to a product-based mindset, was absolutely critical in forming some of the foundation for DevOps. And in terms of Agile itself, what it is focusing on very much is how can we get our software into the hands of end users faster? So how can we get our products into their hands quicker? And how are we going to do that? And part of this is delivering more often, delivering regularly. It is a really active collaboration piece. So where there are barriers between teams or barriers between individuals which stop us sharing knowledge around what works and what doesn't. How can we break those down or improve them? How can we start to maybe improve the trust between different teams and different practitioners in our organization? And the focus of Agile in part was on this cultural, building this cultural trust and these cultural bonds. But it's also about looking at the efficiency and simplicity of what you're doing. Are you introducing steps in the software development process or in our process to release software into the hands of customers, which are introducing hurdles or blockers? Is there something there which has existed for a long time and actually we can remove that from the equation and therefore get to this value easier? And it's all about kind of satisfying customers. So you can see very clearly that there are principles here which are going to have a real positive effect and kind of move away from a almost kind of monolithic approach to delivering projects which take a long time. Actually, can we drastically reduce the amount of time we're spending on releasing to customers? So I think that's a pretty core foundation for this. I think the other aspect to this is definitely around lean. The Toyota production system in the 1980s came up with this as a methodology for analyzing the efficiency of their physical production lines. And lean, you can very quickly see as I start to talk through this, lends a lot of its principles to the field of software delivery. So lean is very much around focusing on bottlenecks and looking at optimizing these kind of physical production lines and removing what was perceived to be inefficiencies or time spent on tasks which aren't necessary to get a material into the hands of an end consumer. So again, very much kind of focused on delivering often. So small batch delivery, can we actually get physical goods into the hands of, out of the warehouse, into the hands of end users? And how can we automate as much of this as possible? So where are we spending a lot of time from materials all the way through to the refined and produced goods? And how can we reduce the friction? And when there is friction and when these bottlenecks do exist, how can we get the expertise of everyone in this process to focus on those inefficiencies and bottlenecks and remove them? And you can very, very quickly see how there are parallels that you can draw quite quickly from lean and agile into kind of what we would consider to be sort of modern DevOps. So what is DevOps really doing? It is focusing on a process of process principles and cultural shift to having a faster and more iterative approach to software development. And some of you might be familiar with these stages of the software development lifecycle. The stages themselves, these are pretty standard, but obviously there are sorts of permutations and differing stages that different organizations use. But typically, when people talk about DevOps and they talk about the SDLC, these are the typical stages that they'd be kind of looking through. So all the way from planning your software to coding, so development activities, to performing builds, and those builds ideally, using technology, using continuous integration, to move to a process of moving work from an idea all the way through to the deployed state. And so you can see this kind of figure 8, this is intended to articulate the kind of iterative and cyclical nature of this. So you would typically have in the old world, the development team creating their products and handing them off to a different team, and they wouldn't really have any sort of ongoing involvement in the operation or the deployment operation of those. DevOps is taking a slightly different approach, and it's saying, look, we are not separate and distinct teams. We should work together. We need to collaborate and own this product. And you might have heard a mantra of, if you build it, you run it and then you fix it. So you own this product. DevOps is very much looking to instill that in a cultural and technological perspective. So this cyclical figure 8, you'll see in many different guises, but it's really intended to illustrate that actually this is, first of all, a continual process, that these different disciplines and these different skills, they work very closely together. And it's all with the aim of delivering software and software into the hands of end consumers, so getting those products into the hands. So we talked a little bit about some of the kind of principles or the kind of foundational aspects. But I think it's really key that we talk about automation. And here at the bottom, we have our SDLC stages. And of course, we need to consider how we kind of segment these and kind of the different technologies which are in use to achieve this automated flow as much as possible from the planning of a software application to its deployment, its operation, and its monitoring. So you'll typically see terms like continuous integration for what we consider to be the kind of plan, code, build, test stages. This is the taking of code from repositories. It's performing a build. It's performing various tests, and then it's looking at how can we actually then deliver that to an environment for example, additional testing, or to move it from staging into a staging environment. And then how can we actually then deploy that into a production environment so that our end consumers can make use of our products. And I think this is intended to give you an idea of the vast array of different technologies at each of these stages that you could potentially use. And apologies if there's anyone from a vendor in this room or online who isn't represented here. This slide is just intended to give you really an understanding of the array of technologies here. And so you can very quickly see that if you're an organization who is looking to stand up DevOps and looking to stand up the technological automation in these different systems, spare a thought for those people who do have to set those pipelines and that automation up, because each of these technologies requires a great deal of expertise to understand how they all play together, and how those technologies can play together is quite a huge task. And so if you think back to this principle about DevOps in terms of having multidisciplinary teams who can own their products, you can very quickly see that even just adding a few of these technologies onto everyday development practices is an awful lot of brain power for someone to expend. So standing this automation up and having software move all the way through this flow is a full-time job in many areas. So we can see here, obviously, technology absolutely key to DevOps. I think as well as the technology, though, you need to bear in mind that it is actually only part of this. So CARBS is a kind of acronym which was popularized by Jez Humble. And this is the idea that actually the suitability for an organization to adopt DevOps is based on lots of factors. As technologists, we probably gravitate towards the technology because we enjoy it and we like playing with things and tinkering with things and getting things up and running. But actually, there are a lot of cultural aspects around this move to DevOps, which we also need to consider. So are people open to change? Are they open to sharing their knowledge? Are they open to maybe putting their hand up when things aren't going particularly well and getting assistance and contribution from colleagues? Can we adopt automation in our organization? Do we have the tools and expertise? Do we have the capacity to do this? Are we thinking in a lean manner? So are we considering whether our processes are burdensome? Are there bottlenecks? Are there time sinks in our process which we can remove? So lean is all about thinking about this picture and trying to remove it. But also, are we in a position to start measuring how we're doing automation and DevOps? So can we measure, for example, a lead time from a product inception to being released? Can we look at measuring the duration of our pipelines? So measurement and saying, actually, we need to think about what we're harvesting and use that to continuously improve what we're doing. That is also a key part of this puzzle, as is sharing. So this piece of, rather than, this is my kingdom and this is your kingdom, actually, can we share this knowledge and can I go forward? So when I'm talking with customers, I think the overriding consensus is understanding that DevOps is about consistent and standardized automation is important. we need to think of this mindset and this kind of these principles as being around open collaboration and sharing, looking with an honest lens around what we're doing, and are there things that we can optimize? Are there things that we can remove to improve the flow of work and the delivery of value into our end customers? And just coming at this with a continuous improvement mindset. And I want you to bear this in mind, because when we talk about security later on, this is equally as important when considering security as a part of DevOps. But ultimately, it's about focusing on the customer and the user and optimizing those constraints. What DevOps isn't is a single tool or technology or something you can buy in. I think there can be this kind of preoccupation with the technological side. I would argue that it's far harder to get the cultural shift and the cultural view of moving people towards this open collaboration and sharing. That is much harder than just the technology, although the technology has challenges in and of itself. It certainly isn't easy or quick to implement. So I have had customers say, can you just give us some guidance on how to implement DevOps? It is certainly not straightforward. It takes many years to adopt some of the cultural and behavioral principles that relate to this. And also, it might not make sense for every team to completely change their structure, adopt a kind of multidisciplinary approach, and kind of restructure themselves for DevOps if, for example, they are only releasing very, very infrequently. They have a piece of software which is just kind of on life support, that sort of thing. So it's not only for developers. I think it is a cultural shift. It is a mindset, and I think some organizations perhaps lose sight of that, and it becomes the new thing to implement. But actually, having this awareness of what it means as a whole is important. So this slide is just intended to give you an idea of the types of definitions you'll find for DevOps online. If you type "what is DevOps" in, you are likely to see lots of different definitions. I would say there's no one definition that's better than the other. I don't expect you to read these. What I am trying to articulate is that they are the same core ideas, just expressed slightly differently. So this is just indicative of those different definitions. So we've talked a little bit about DevOps, and I think that's important to understand some of the context, especially for those of you who are watching this or are coming to this as an entirely new topic. But now I want to just shift gears a little bit and talk about DevSecOps. And DevSecOps as a term is something which some practitioners who have been working in DevOps and have been working with these different principles for some time would say is not needed, because we consider security part of DevOps as a fundamental core. However, DevSecOps as a term is popularized. It is obviously included also in the name of this group, and some people say this is necessary to raise awareness of the importance of security in DevOps. So I want to paint a picture for you of the mid-2010s. Obviously, people very excited about this automation and DevOps, very excited about working on pipelines, lots of challenges there, lots of vendors and providers of technologies working to improve the automation capabilities of their software to fill this need. And you have people who have kind of built up these expertise. We have organizations where developers are working certainly more efficiently to develop software and to deliver those features into the hands of end customers quicker. So they're working more efficiently. You're starting to see in a lot of organizations, a lot of teams, this culture shift towards this more open collaboration and communication. And this is just paying kind of various benefits to different things. You're seeing a release to the velocity of your software, increase in the release velocity. And ultimately, this benefits consumers because they're seeing actually products enter their hands faster, and these products are being iterated on quicker, so they're seeing new features. And obviously, this helps with businesses seeing improvements to profits and customer retention. If you can demonstrate to your customers that you can develop new features and deliver them regularly, then they'll see the benefits of that, and hopefully you'll kind of retain those customers. However, there is one aspect to this which wasn't quite as rosy, and I think that is to do with security. And when we look at the reasons why security wasn't included, or maybe not thought of as integral to this shift, this cultural shift. I think it's quite interesting. So first of all, I think the automation piece wasn't as developed or as progressed as it is now. So very much application, security vendors struggling to keep up with the pace of automation that maybe other vendors were. So when security became a consideration for these teams, for these DevOps teams, it was very much a case of, well, you now want to do manual processes, or you want to perform some kind of security check, and this isn't keeping pace with this release velocity that we've come accustomed to. So you have this point at whereby this perception of security is that it is now almost a secondary consideration or a bottleneck, or something preventing those teams from actually getting their product released, getting it into the hands of end consumers. And this kind of lack of automation is, you can see, very much at odds with the idea of optimizing your pipelines and kind of removing bottlenecks and enabling the flow of work through to end consumers and that product into the hands of users. So this little or no automation of kind of security scanning is really kind of hurting this picture, and it's further contributing to this idea of the bottleneck or it being a secondary consideration. And twinning this with the development or emergence of new architectures, for example, emergence of microservices, different artifacts, the definition of what a piece of software is starts to change. You get this huge volume increase in these artifacts, means that if you're responsible for your application estate, if you're responsible for monitoring the software risk, you can see very much that risk start to balloon, because you have many more pieces of software, a lot more of it's actually in production. You maybe even don't have visibility of everything that your teams are putting into a production environment or are accessible. And so certainly from a CISO perspective, lots of sleepless nights when you think about actually how is this risk growing. So this application estate starts to take on many more forms. The risk, the estate grows, and also twin this with the emergence of many more security incidents becoming publicly reported. International press, regulatory attention, and record fines mean that it is more visible now than ever. So people are starting to see their reputation publicly shown or called into question, because they're actually at the top of the news cycle, or the board is just unhappy about the type of attention that they're getting. So obviously there is this kind of renewed interest and emphasis on how can we reduce our risk and how can we protect our reputation and profits. So what does this mean from a kind of security perspective? Well, unfortunately, for those people who spent an awful long time putting together their beautiful pipelines, it means that we're actually going to need to revisit that SDLC and consider, are we thinking about security at each stage of that SDLC, and what are the controls and how can we monitor what's happening here so that we can start to gradually improve our risk posture. And there are numerous different technologies, numerous different approaches to doing this. There are pros and cons to each. I'm not going to go into that in great detail here. If you are tasked with improving the security of your SDLC, and you are thinking about at what stage do I include or exclude certain types of scanning or types of security, this in itself becomes an incredibly complex topic to tackle. But what is clear is that taking those principles around DevOps, around the open collaboration, around the cultural shift, around optimizing pipelines, removing hurdles, around measurement and sharing, those all need to be applied to this security lens as well. So you're thinking about actually how can we make sure that we're considering security as part of DevOps. Which is quite a good representation of what the DevSecOps principles are. And one of the key parts that I regularly speak with my customers about is, or one of the key stakeholders I talk with in that I'm working on this topic, is security, governance, and risk individuals. And those people have either been hired by their organization to implement these risk controls and security controls, or they are very interested parties who say, actually, we've got this huge application estate, we've got all of this software, none of it is secure, and we know that we need some help from a security testing perspective to move us to this more secure posture. And a lot of the time they are running up against that historical perception of security as something which slows down teams, which puts unnecessary hurdles in place. And they're saying, actually, how can we change the mindset of our business, of our stakeholders, and of our teams to not see security and what we're doing as being a blocker or something which must be. How can we get people to think about this in kind of a DevOps fashion, using those principles that I've described, and get people thinking positively? And I think a really key part of that puzzle is to have developers and people who are developing software, whether it's developers or otherwise involved in that process, to start considering that a secure product a quality product must be secure. So the security is a key component of a quality product. If you release a product and it isn't secure, well, it's going to impact your customers negatively, or it could potentially have huge ramifications for your business. If you release something that's insecure and an individual is subject to an attack, then that is going to have really, really negative consequences for them. And I think when I speak with developer communities in my role, they are very much about releasing fast, getting new features into the hands of customers. But I think you're almost doing customers a disservice if you're not creating and developing and releasing something which is secure and a quality product. So the security aspect, I think, requires something of a shift in mindset. Of course, that's not carte blanche for security teams or anyone introducing security into the SDLC to introduce as much security as they can without any consideration. It needs to be done in a collaborative and kind of partnership manner. So obviously, whenever you're introducing security, you need to do so in a staged approach, which employs all of these principles that we've talked about: sharing, collaboration, lean. Are we introducing things that we don't need to? Can we cut this down? Can we optimize this? How can we measure the impact that introducing security has? And don't introduce unnecessary bottlenecks. This is possibly my favorite bottleneck over the past few years. It's the blocking of the Suez Canal by the Ever Given. And this is exactly where we don't want to get to, with lots of boats waiting to get to come and go. Probably need to update this as reference soon, because it's falling out of the consciousness. But yeah, this is definitely my favorite bottleneck of the past few years. But I think, regardless of who you're talking to, if you want to release products in a rapid and efficient way, and do it in a way which protects your customers, protects your business, and also protects the careers of the people who are working on that software, you need to do it in a measured way, which introduces these controls and introduces these different ways of security testing without impeding the flow of this work too much. And it's a very tricky balance for my customers and anyone who's introducing this throughout the SDLC to achieve. And it's certainly something which I don't think organizations should expect to get right straight away. And when I talk with my customers and the people that I speak with regularly, it's very much a case of, look, we need to apply these principles of feedback and improvement to this as much as anything else. We will start at this point. We will increase a threshold, or our appetite for risk will change, or we'll introduce this control, or we'll introduce this security testing type. If it doesn't work, that's okay. That's part of the process. let's go back and remove that, or let's alter that threshold, or alter what we accept as acceptable risk. So again, lots and lots of definitions for DevSecOps. This is just intended to, again, emphasize the fact that there are lots of definitions, but they really do have these kind of same core ideas. But of course, the principles that I think are most important are just really considering security as part of this overall cultural shift, and just getting people to think a little bit more securely about what they're doing. One of the very interesting talks one of my colleagues gave recently was to a group of developers, and actually telling them, instead of just wearing the maker hat, put your breaker hat on. So try and break your own application, try and exploit weaknesses, think about where someone might try and take advantage of something. If you don't have a threat modeling process, consider how you can just have a kind of short discussion to just think of hypotheticals in terms of how someone might exploit something. So if DevSecOps, lots and lots of benefits for this for organizations. What you should get to a point to over time is continued improved awareness of security. And so what you want, the ultimate grail that my customers are trying to get to is having apps just be consistently secure by design. So whether you're thinking about your first party risk, so that's risk in code that you've written for your software, or you're thinking about open source risk, you should really be considering this actually before you start to develop something. So can you draw upon vulnerability information from various databases or tools? Can you think about security education in relation to what you're going to be developing before you start developing? And what I have seen and what my customers experience is that by going through the process of raising awareness of security as part of DevOps, they are starting to gradually have people think, actually, we are introducing this new feature as part of a capability. What are the security ramifications of that? And you start to grow this sort of pervasive mindset. But really importantly, we want to do this work, and we want to be introducing security and have people think about security. But we want to measure that, and we want to gain insights on what is working, what isn't, and how we can improve this. But if you start to really sort of aggregate some of this data, start to harvest some of these metrics and some of this information, you can start assist in other processes. For example, reacting to incidents. For example, if you wanted to understand how many of my applications are using a certain open source library, for example, having this data to quickly enable you or others to make changes to your application, to respond to vulnerabilities, is just kind of one of the benefits of having this pervasive mindset, but also this security testing and this security observability across your estate. Of course, what people ultimately want is reduced attention for organizations because they are securing their applications. You don't have to worry so much about fines, but also you will find that actually addressing security earlier in the software development lifecycle, so having built out as part of that figure eight, that cyclical figure eight, fixing your findings in applications earlier, addressing the security, improving that posture, it actually has lots of savings from a cost perspective. So later on in the development lifecycle, when you're, for example, looking to release your software, if at that point you consider the security and you do a couple of scans, different scan types, you may well find findings which require you to re-architect the application. It might relate to a module that a developer worked on months ago, and now they have to contextually switch and try and get everything back in their heads that they were working on at that point. And developers cost money. Everyone who is working on these applications, who is working to try and develop something they're proud of and get it into the hands of end consumers, wants to do the right thing, and they want to do things in the most efficient way. Unfortunately, if you only introduce security at the end of that cycle or close to release, then the potential for additional costs spent on fixes or trying to remediate the security posture starts to ramp up. And of course, if you can secure your software through the SDLC, throughout the SDLC, and to use the terminology, shift left, get people looking at this risk earlier on, even hopefully before they sort of start coding, you can manage that risk better, and you can actually just spend more time on new features rather than having to kind of go back and try and re-architect or rework certain aspects to the application. And of course, as a business, if you've got efficient and effective security testing throughout your SDLC as part of DevSecOps, that really gives assurance to various stakeholders in the business, and the overall risk posture as a result of this improves. And I think one of the things that I talk about very much in respect of the technologies that I work with at my company, but regardless of technology, is a foundational principle, is that this mindset of how can we measure what we're doing, improve, how can the flow of feedback be built into what we're doing? It applies to more than just technology. It also applies to things like education. If you have pipelines set up, if you have your SDLC automated beautifully, even with security testing, you might find that actually the bottlenecks are educational. They are where people don't know how to address something from a security perspective. And so trying to identify ways to remove those kind of knowledge bottlenecks is as important as removing the bottlenecks for the technology itself. So this diagram is intended to show is that this continual feedback loop and continual education and risk reduction is equally as important as having all of these technologies set up perfectly, because you want to be using the metrics and the findings and the aggregation of knowledge to improve education from specific teams. I'm sure everyone here has been through, for example, training that they were forced to do, mandatory training, and it was an absolute pain. And they would, much rather do anything else than go through that. So, and one of the pitfalls that some of my customers go through sometimes is they will enforce training on every security topic for every team. Actually, let's think about this in a more targeted approach and a targeted effort for this. Let's actually have a look at the security findings that particular team is experiencing and tailor the education that we have so that they don't feel like they're doing something which is completely unrelated to their day-to-day activities. So, like I said, I think we generally gravitate towards technology and how we can get this operating efficiently, but there is a real cultural aspect and a behavioral aspect to this work, which is equally as important. And that is a journey which is certainly not a short one to get to a point where everyone is considering security. And I have various conversations with people about, can we do this talk? We have lunch and learns, can we get people engaged? And I really sort of say, let's set the expectation here. This is a shift which is going to take years to achieve and to get to a point where people are thinking habitually about security. So, I tell people not to be so hard on themselves when they don't see the results they need, but this is all a kind of process of continual learning. So to summarize in terms of this, the slides that I've gone through, I think DevOps and DevSecOps, as you've seen lots of definitions, it's the same core ideas. It's this idea of the people who are involved in things, looking at the processes that people are using, how to optimize them. And it's also, of course, it's the technology as well. DevSecOps as a term, some people agree with it. Some people think the security shouldn't be needed because that is a fundamental part of DevOps. But really all it means is considering the security as part of the SDLC and building it into the different principles and methodologies that you're using as a core and important foundation for what you're doing to develop software and release it. These are collective movements, right? This is an amalgamation. This talk has been an amalgamation of lots of different ideas, and it is still evolving. And I think for some people, DevOps means a certain way of working, a certain model, a certain team structure. For others, it could be completely different. But this idea of striving to make a more efficient, safe way of delivering products to the hands of end customers is kind of unified. It's not just about the technology. It is very much around people and bringing people on that journey and having them see the importance of adopting certain ways of working and certain practices as well as technologies. And people like what they know. They like to stick with something that they think works. Actually, DevOps and DevSecOps is about looking at that and saying, how can we iterate on this? How can we improve it? Let's not just take what we have for granted. Is there something that we can adopt which will make this better and make the flow of work more seamless? Or actually, are we using something which we can remove from this because we don't need it anymore, or it's extraneous to requirements? But there are also, lots of benefits to securing software, and considering security as a kind of key characteristic of a software product, I think is key to getting DevSecOps as a notion and as an ideal adopted in an organization, because people take pride in what they do. And if you're taking pride in developing software, you should also take pride in the security aspect. So just some further reading if you're interested. These are some relevant books. The Phoenix and Unicorn Project are excellent, excellent kind of novellas in a way that you can actually read it, not dry at all. So I would absolutely recommend using those and kind of reading through them. The DevSecOps book at the end is fantastic. Glenn is involved in one of the other DevSecOps London gatherings. An excellent read as well. So I would highly recommend looking at these resources just for some further information, or if you want to just kind of learn more about different aspects at a slightly more depth level. And that's it. So thank you all.
I'm going to check online, see if we have any questions online.
You had a question about containers and the way to go, I think.
Okay, so let me just sort of make sure So I'm just checking, giving people a chance to type, because it's harder for the people online.
Okay,
So first of all, thank you very much, Nick, for going through that. And I particularly like the sort of the mind game that you were playing in terms of, is DevSecOps really necessary? If we were doing DevOps properly, maybe. Yeah. I think it's a really good call. Yeah. Those weren't quite your words, but I'm reinterpreting it.
Good paraphrase.
Yeah. And I think that's a really good point, because if what we're saying there is, is software development being done properly if it's not considering security?
Exactly.
Yeah. DevOps is a way of helping assist software development work efficiently, especially in the world today where we've got agile processes, as you said. Making really rapid releases, automation is necessary. You just can't live without it. But it also helps from the point of view of reproducibility, accuracy, and as well as efficiency. Yeah, because if you can, what I like to think about automation is, even if you get it wrong, as long as you're doing it consistently, that's better than doing it manually, inconsistently. Yeah, because you can sort that out.
Yes.
Yeah. What's really hard is when you've got a problem to solve and humans are involved, because we're not always consistent, in terms of how we do things. Yeah. So that's one of the great benefits of automation. Okay, so let me have a look. I've got a couple of questions that I've spotted along the way, so let's just see. So we've got a question here from Raymond. I'll have to sit down. I can't drive this thing and stand up. So Raymond asked, is there an open source proposed architecture for secure software maintenance? So I suppose what he's getting at is, if we look at sort of approaches, frameworks, is there anything out there that was like an open source framework
So open source, I mean, you have things like OWASP, who will obviously provide you with a wealth of information in respect of prominent flaw categories that can arise in software, common weakness enumerations, in respect of first party your flaws in code that you've written. But there's various frameworks and structures that you can adopt. There is a lot of variation amongst both my customers and in the wider industry around what people assume to be a priority from an attack perspective or from a governance perspective. So there's lots of resources. I can maybe share some of those after the session.
Okay. And then I think his next question is about, and really I suppose what's the implications of working with containers? How does that change what we do at DevOps and DevSecOps?
I think it's a really interesting point, because what people consider to be a software artifact, which is the subject of security scanning, is changing, and container security is equally as important when you're thinking about exposed secrets or misconfigurations, vulnerabilities in infrastructure as code. So considering your images and considering what you are basing your images on, and are they secure before they're containerized, I think is a growing concern. So the ability to scan containers pre-runtime, as well as monitor runtime containers, I think is a very important point. Obviously, I work for Veracode. Veracode is a security testing vendor which very much focuses on the pre-runtime side of things. So we are helping people secure their applications, to secure infrastructure as code and containers pre-runtime. But obviously there is runtime container protection as well. I think, like any other software artifact, you should consider, is it configured correctly? Are you bringing in open source risk where you don't need to? And I think that's probably a very large concern for most of the customers.
I think that's a good point. I mean, containers introduces new things, and it is a complex topic as well, isn't it?
Yep.
Yeah. So I think it's good that was called out.
Yeah.
I think the answer is complicated because the subject matter is complicated.
Definitely.
Yeah. Okay. Okay. I've got a question here from Christos, and let me read it out. So first of all, he says, "Thanks a lot, Nick. That was a great presentation. The exponential rise of AI and the disruption it brings on the way we develop products and software, using tools such as GitHub Copilot as an example. Do you have any thoughts or proposals on what changes we need to make to our secure software development lifecycle and therefore DevSecOps processes to adapt in this new emerging world in order to achieve our security goals?" So really, what's the impact of AI?
That is a fantastic question, and probably something that you could talk about for 2
Probably
hours.
So in a few minutes.
So I think a really important consideration when you think about AI and security remediation or identification is, first of all, understanding that large language models, AI, they draw on data sets, and the quality of what you get out of an AI solution will be dependent on the quality of the input and the quality of the way that the model is trained. And so if you're thinking about security remediation assisted by artificial intelligence or large language models, then that is thinking about the inputs to that model is incredibly important. But it's also important to emphasize that the critical thinking that goes along with the use of what you get out of something which is AI assisted is as important as what it spits out, because anyone who has tried to have a solution write a pipeline script for them will know that they are full of inaccuracies, and they will give you an understanding of how something might be achieved, but actually it will need some expertise to actually think critically about it and then understand what weaknesses or what potential application it might have. So if you're thinking about AI assistance, it is certainly the future for security testing. However, it is not a replacement for the critical thinking of whoever is taking the outputs of that, and they're structuring their applications and they're structuring their decisions, because it is very much in its infancy. Its accuracy and will improve, but the critical thinking aspect of using these tools cannot be downplayed.
Right, so is there any questions from people in the room? Anybody in the room want to ask a question or clarify anything with Nick? Yes, yeah,
So there are quite clear guidelines about what DevOps is and how it's implemented, like the diagram that you showed is quite popular. Even then, different organizations and even teams within the same organization implement DevOps differently. What are the challenges there? Because when I interview for a DevOps role, I hear different things. Like you mentioned, automation is quite a key part of DevOps. But I think DevOps became a very fancy job title at one point of time, and system admins became DevOps.
Yeah.
So there's still a lot of, so when I interview, I have to specifically ask, what's the split between development and operations? And I still hear manual work is 80% and automation is 20%. But they call themselves DevOps. So what are the challenges that you see within the industry? Because
I think the real challenge is that when people originally envisaged that there would be a multidisciplinary team of people working in DevOps, they assumed that people would be able to understand and learn everything about all of the technologies involved. And it's quite aspirational, but also pretty unrealistic when it comes to having a developer understand multiple languages and frameworks, then understand all of the automation needed to stand that up, build it, deploy it, and test it. And so what people consider to be a model for DevOps, so a team full of individuals who have all of this knowledge about everything and, you know, completely omniscient, is not a model that a lot of the organizations I work with employ, because you can't have someone who understands absolutely everything about every technology and is able also to look at all of the reporting and the sharing and the cultural, and it just becomes completely overwhelming. So many organizations don't use that kind of topology and don't use that kind of model because they've tried it, but they found it's unsustainable. But that doesn't mean to say that in those large organizations, they have pockets of teams that can operate in that fashion. Many, however, will have a dedicated DevOps team or a DevOps platform team to serve those requests that come from development teams. So it's really changeable. And I can see there's a hand up there. Can you go ahead?
I've got to say, like your namesake, I love the idea of the attack as a way of looking at stuff. And I love the quote that you've got from the JIRA Atlassian people who disappeared off the face of the planet for nearly 2 months at one point. But I'm minded of your first really nice, rich slide where you had JIRA, you had the entire chain in the CI/CD pipeline. So I tend to look at stuff generally slightly differently because of this attack. And the US federal agency, CISA, they have a catalogue, and recently they put one that for me is like this year's Log4j. And I just wondered if we looked at that map, because I think of it as a map, and specifically it's the dynamic loaders for the GNU CC compiler. And to me, that's like everything's affected and no one's noticed. Have you got a view on that map as to what proportion of it do you think is going to have to be rebuilt? You know where I'm coming from, don't you? Basically, one open source GNU component, as we saw with Log4j with enhanced login and stuff last time, a couple of years ago, it's all it takes to basically say the king has no clothes.
Yeah. So, and that observability is, I think, something that a lot of organizations are striving for.
But it's the entire map. If we looked at your map, I'm thinking everything along that supply chain. I couldn't quite read one of them, it was too small, is affected, and that's one single GNU enrichment library process, which means your entire stack's got to be rebuilt at every level, every component, every library is now subject to buffer overflows.
And having this auditability of components and software and what is using which component, etc., that is a huge.
And then it begs the question, so specifically, if you are required to justify your decision making in that end-to-end CI/CD pipeline, I'd be really interested in which of those bits of the stack you consider to be artifacts where a decision was made. Does that make sense?
It does, yeah. I think
I'm not saying you've got an answer.
I certainly don't have an answer for that, but
Has anyone ever asked you it before?
So what you're talking about is software supply chain security, right? So
It's beyond that. It's beyond that. It's the entire philosophy. So there's an aspect that isn't even considered yet.
And the full traceability. I think that's.
Yeah, that's a fair one.
That's really what you're talking about, David, is can
going
you
beyond.
demonstrate full traceability of all of the software and the components that are being used?
That map,
And
that CI/CD map for me was
But if-
rich.
But if you think about that in the full, absolute, widest breadth, it's not just the software artifacts that are being used to construct the product. It's all of the other software artifacts that are part of your CI/CD pipeline as well.
Which become
Part
an
of your
inherent
runtime
decision.
Yeah.
Yeah.
And it's so where do you stop? Yeah. So what I'm going to suggest is we got some good topics there that people might want to sort of mull over when we break off in a second. I've just got one other question here that I wouldn't mind asking is, so somebody was asking about, is there anything so the question was, any advice on developing a secure application testing mindset beyond OWASP? And I think maybe what David was referring to then might be part of the answer, which is maybe the MITRE ATT&CK framework. So if people haven't come across that, perhaps that could be something that is a good another thing to look at.
it is. I think
The framework.
I think there are lots of frameworks that
Yeah.
you can adopt. They can take an awful lot of work to actually implement. And I would say out of my customer base, a very small percentage are using the MITRE framework, and they are struggling with just the observability piece.
Yeah.
I
would. It is big.
it's
Is
very
huge.
aspirational.
And my view on MITRE ATT&CK is there's some really good material in there. Go and be inspired by it, but don't necessarily be wedded to it.
Yes.
Yeah, it's got some really good, very, very good content, but just don't feel you have to do all of it. I think perhaps that's what you're saying. I wouldn't mind just asking a cheeky question of my own. You touched upon people going through and measuring things. You got any top 1, 2, or 3 things that people might want to measure when they're going through?
From a security perspective,
Whatever.
I mean, if I think
Doesn't
about
have to be.
the metrics that are important to my customers,
Yeah.
the time to resolve findings is a key one. I also have customers who are very interested in the policy compliance of their software. And when I say policy compliance, I mean these are defined rules that they have specified that software must meet before it's released. So, for example, no very high severity findings or high severity findings or vulnerabilities. So they don't have time to look into the minutiae of the security posture. A lot of the time, they just want to know, what does our production risk look like? And the time to remediate findings, the volume of findings by severity across different applications and different security testing types is very much a number that is at the forefront of CISOs that I speak to. But this kind of overall policy compliance and this risk view, that is a key metric and a key indicator of, are we safe in our production environments? Is my organization safe? Or actually, do I need to introduce education, help, assistance, or additional tooling to get that position?
I think that's a really good place to end, because And this is the difference, to my mind, between DevOps in its sort of original form and DevSecOps, which is DevSecOps is typically much more concerned about trying to manage risk than a lot of people think DevOps was. So thank you very much. And just like everyone to thank Nick again. So thanks everyone online for your questions. If I haven't been able to communicate properly, apologies. You know where I am. My email address is on the website, so you can get back to me that way. Thanks everyone, and we will talk now. And for those in the room, if you do want to stay, if you can stay and want to ask Nick any further questions, we're going to go next door where we've got some refreshments. Is that right, David? We definitely have some.
Some thank yous coming up if you look behind you now, gents.
Yeah, okay, so absolutely. So yeah, so thanks for passing thank yous on everyone. That's really good. Yeah.